James C. Mather, the James Webb Space Telescope, will observe the first galaxies to form in the early universe, peer behind clouds of cosmic dust and gas to see stars forming, and reveal new details about places like Europa and Titan that may harbor life. Scientists didn't expect this. The James Webb Telescope saw strange galaxies, and there's nothing more we can do. This new, high-powered telescope should answer some of mankind's oldest questions, and the latest research results are always exceeding all expectations. The old laws of the universe are falling, and there is room for completely new definitions. Are we now getting closer to the true origin of the universe? Did the Big Bang possibly never exist, or was our universe born out of a black hole? Galaxy 13 is a galaxy that is so old it cannot be explained using standard cosmological models. The galaxy, which existed only 325 million years after the Big Bang, offers us a rare insight into a distant era of the universe and a time that has been largely unexplored until now. Galaxy 13 is remarkable not only for its enormous distance from Earth but also for its importance to our understanding of cosmic history. This galaxy offers us a direct view of conditions in the universe at a time when it was supposedly just beginning to form its present structure. But James Webb's observations show that this was not as our scientists calculated. Galaxies like this one should not even exist according to the old explanations. Galaxy 13 is too large, too perfectly structured, and contains too many old stars. This discovery, and the sighting of 14 other very old and highly developed galaxies, raise completely new questions that shake the foundations of astrophysics and cosmology. The light from Galaxy 13 took billions of years to reach us. This enormous distance means that we see the galaxy as it was a long time ago, and we see with it into the past and close to the Big Bang. James Webb's range is about 13.5 billion years. Hubble could also see almost that far, but Hubble was not able to provide usable data from that epoch. James Webb was built in such a way that it can still elicit great secrets from even the faintest light signals. Every light wave collected, traveling billions of years through space and time, tells us something about the source from which it was emitted. The light from the 15 strange galaxies tells us that these fascinating objects are quite different from what we expected due to their composition, structure, and the conditions under which they formed, and that they cannot possibly fit into previous assumptions about star formation and galaxy formation. The earliest epochs of the universe were not only the times when the first stars and galaxies were formed, they are the foundations of our physics today. The discovery of Galaxy 13 not only put some of our exciting theories about galaxy evolution to the test, but the very foundations of astrophysics. The discovery of Galaxy 13 by the James Webb Telescope is a milestone in astronomy and a wake-up call to science. Peter Van Duckham says, "It's true, the JWST images seem to show that there were many galaxies in the early universe that were as rich in stars as the Milky Way." Peter Van Duckham is an eminent astronomer and professor at Yale University. Duckham has made a name for himself, in particular, through his innovative research using state-of-the-art technologies. The astronomer gets to the heart of the matter and was one of the first scientists to comment on James Webb's incredible observations. He was not one of the scientists who doubted the authenticity of the measurement results. He recognized that it was true and that galaxies such as Galaxy 13 were closer to the Big Bang than we had previously assumed. This hypothesis would fundamentally change our cosmic history, and this is exactly what many of his colleagues did not want to accept. Duckham sees the discoveries as an opportunity for science to recognize old mistakes and finally get closer to the truth. For the Yale researcher, the fact that galaxies the size of our Milky Way already existed 300 million years after the Big Bang is an exciting task that the universe now presents to scientists. We can look forward to seeing what new paths in physics these discoveries will show us. The new research will certainly lead us to a completely new understanding of the Big Bang and its consequences. John Marr holds on to the Big Bang. A quote from John Marr, "I am almost certain that there is something wrong with our previous models of star formation." For John Marr, the father of the James Webb Telescope and a pioneer of astrophysics, one thing is certain: yes, we see galaxies in the images that are so old that they do not fit into our current cosmological worldview. However, the astrophysicist and scientific director of the entire James Webb mission does not doubt the Big Bang. John Marr believes much more that we need to rethink our theories about the formation of the first stars and galaxies. Ma is a luminary in the study of cosmic background radiation, which is used as one of the main sources of information for all theories and evidence surrounding the Big Bang. This radiation, which can still be measured in space today, is regarded as a direct relic of the Big Bang. Ma was awarded the Nobel Prize in Physics for his work, and his opinion carries weight among experts. Previous models of star formation assumed that the universe was initially far too hot to support the formation of solid matter. It took hundreds of thousands of years for particles to form their first bonds and molecules to form. From these, eventually came together to form clouds of dust and gas from which the first stars were formed. These stars then slowly came together to form groups. Billions of years would have passed before highly developed galaxies danced through space. But James Webb shows us that highly developed galaxies already existed a few 100 million years after the Big Bang. According to these calculations, the first stars must have been gigantic blue supergiants that burned up after a short lifetime. So far, James Webb has not found any traces of these so-called population 3 stars. All we see in the images are beautiful and complex galaxies containing stars of all ages. As senior project scientist, John Mather played a crucial role in the overall development and deployment of the James Webb Telescope. His vision was to develop a telescope that could show us the first stars and galaxies, and James Webb has now done just that. The mission is successful, and the rest is now up to the scientists. Some will have to say goodbye to old theories, and new concepts are already surprising us. New scientific findings, no dark matter and no dark ages. Imagine a Big Bang in which ready-made stars shoot out of a black hole like fireworks from a rocket. The Big Bang could have looked like this, or something similar. Does that sound crazy? But scientists could now come to exactly such new conclusions. Most recently, researchers from the University of Chicago and Princeton University presented a paper suggesting that a black hole could have been the midwife of our universe. Classical physics and quantum physics have agreed that before the Big Bang, there was a quantum fluctuation that produced no measurable force or matter. Some observer event then ensured that this state of absolute equilibrium was suspended at a single point. The observer can cause the nothingness of the quantum fluctuation to take shape and form matter. This has been proven several times in quantum physics. The moment at which this moment of observation occurred immediately preceded the Big Bang. Scientists from Chicago and Princeton have proven that the minimal radiation at the edge of a black hole can play exactly this role of observer. So Roger Penrose, the famous British astrophysicist and consciousness researcher, introduced his concept of the cyclical universe a long time ago, according to which our Big Bang was the result of a predecessor universe at the end of which gigantic black holes had sucked in all matter. These black holes could have been the midwives of the new universe and thus have outlasted universes. In addition to the very old galaxies, the James Webb Telescope found evidence of the real existence of ultramassive black holes close to the Big Bang. All these facts could support these new theories. But what would a cyclical universe mean in practical terms? The question can be answered in several exciting ways. Firstly, it would mean that our universe is essentially immortal, just as Eastern religions imagine our existence as entities in the universe as an eternal cycle of birth, life, death, and rebirth. Our universe could also exist. This would mean that creation is infinite in time and possibly also in space. As the work of Roger Penrose and other researchers who postulate something similar also show, there can be several universes at the same time and in the same space. It's possible that completely different information and building blocks of matter existed at the beginning of the universe than previously assumed. Black holes could have spit out all the information that they swallowed in the old universe into the new one and thus created matter, stars, and even entire galaxies much earlier. Then our universe would have been populated by stars very early on, and there would have been no dark ages as previously assumed. Of course, at the moment, we cannot rule out the possibility that the Big Bang took place at a completely different time. The Indian-Canadian researcher Rendra Gupta presented a convincing paper according to which the universe could be 27 billion years old. Gupta's calculations omit the controversial dark matter and instead refer to a modification of the effects of gravity. These new concepts prove that there are alternatives to the previous standard cosmological model and completely different coherent explanations. The Webb telescope already represents a quantum leap in astronomical research with its advanced technology and unprecedented ability to observe the early universe. The telescope opens the door to new discoveries and insights. The now urgently needed re-evaluation and adaptation of existing cosmological models can only mean more truth and knowledge for us. The theory of the Big Bang was not certain even before the appearance of James Webb. It made mathematical and physical sense, but no one had ever seen the Big Bang or the Dark Ages when no stars show. This is only now becoming possible thanks to new technology. Subscribe to the channel now, there are many more exciting video hits to come.